Good morning, and welcome to today's Forum 360 on the role of AI and autonomy in military aviation. Although crewed aircraft remain an important part of modern force structures, the world is trending towards human autonomy teaming and uncrewed systems that increase standoff, provide force multipliers, enhance survivability, and make possible new operating concepts for future missions. Today's session delves into the technical advancements that are enabling the next generation of collaborative combat aircraft, or CCAs, with a focus on how AI and autonomous systems are being designed, tested, and deployed within cutting-edge military programs. Today, we've assembled 6 expert panelists from the Canadian Department of National Defense, United States Air Force, Anduril, Northrop Grumman, and Lockheed Martin, who will speak to their work in this era of great power competition. I'll briefly introduce each of them. However, their full biographies are available on the AIAA Aviation Program. First off, to my left, we have Lieutenant Colonel David Dunwoody, who is the Deputy Director for Data and Analytics Enablement at the Canadian Department of National Defense Digital Services Group. He effectively serves as the Canadian Armed Forces Advisor on AI. Originally trained as an Air Combat Systems Officer, he served on multiple deployments, including remote piloting the CU-170 Heron in Afghanistan. To his left is Trenton White, an aerospace engineer at the Air Force Research Laboratory, or AFRL, currently serving as the corporate portfolio lead for autonomous collaborative platforms in the Aerospace Systems Directorate. Trent specializes in configuration aerodynamics, multidisciplinary analysis, and design, and previously served as the manager of the Off-Board Sensing Station program, which resulted in the XQ-67A. Next, we have Lieutenant Colonel Taylor Wilson, who is the commander of the U.S. Air Force 40th Test Squadron at Eglin Air Force Base, where he leads the developmental test of over 75 active acquisition programs, including the CCA arm of Next Generation Air Dominance, advanced weapons and kill chains that enable strikes of high-value targets in contested environments, and the weapons design for the B-21. We also have Dr. Sean O'Brien, who serves as Manager of Advanced Autonomy, Research and Advanced Design at Northrop Grumman. Over the past 2 decades, Sean has led teams that delivered groundbreaking capabilities in autonomous systems, activity-based intelligence, human-machine teaming, and ISR missions for various customers within DoD. Peter McCardle is currently Acting Vice President of Integrated Systems at Lockheed Martin Skunk Works, where he leads strategy development, portfolio management, and execution of a variety of proprietary programs. Peter is additionally a retired Marine pilot with over 3,500 hours in tactical aircraft and has experience commanding operational test and fleet squadrons at the 05 and 06 levels. And last but not least, we have Andrew Scar Van Timmeren, the Senior Director for Autonomous Air Power at Anduril. Scar leads the team responsible for growing Anduril's Group 5 autonomous air vehicles business. Scar was previously Vice President at Blue Force Technologies, and prior to Blue Force, Scar served in the US Air Force from the Major Command down to the squadron level, flying nearly 1,000 hours on the F-22. Each panelist will deliver a very brief talk of up to 8 minutes on some of their work, and then following the remarks, we'll be able to engage in Q&A on current trends in autonomy, AI, etc. And as with other Forum 360s, I look forward to receiving your questions that will make this an engaging panel. So without further ado, I'd like to invite Lieutenant Colonel Dunwoody to the podium to deliver his remarks.
Thank you very much. First, I just want to say thank you so much for giving me this opportunity to speak with you. This is an area where I find it incredibly fascinating, and seeing where this technology goes, how we use it. One of the things that I'm hoping to talk with all of you about today is the way I look at this is the most important question we should be asking when it comes to AI and any of the technology is not what does the technology do, but the biggest question is how do we use it? How do we incorporate it into our operations? So a bit of background on myself. As Jeremy said, I'm an Air Combat System Officer on the CP-140 Aurora, Canada's version of the P-3. And I did get to see a lot of the changes with it. As part of my role after flying, I was the Operational Liaison and Acceptance Officer for the Software Engineering Squadron. So before we upgraded the aircraft, our mission system was running on 50,000 lines of code of Ada language. And it's amazing what we were able to do for about 30, 35 years with that technology. But being that liaison between the operational community and the software engineers really gave me a fantastic perspective of how we need to work together with industry and with the operators in order to meet those requirements. I also was very fortunate in 2011 to fly the CU-170 Heron UAV in Afghanistan out of Kandahar. I will say it was one of my proudest deployments because I knew that the work we were doing was saving men and women on the ground and making sure they could come home. Worked with a lot of our allies partners, especially the US military, UK, Australian, so a fantastic experience with that. But it also gave me a really good appreciation of the challenges with that human system integration and the design. It's when we look at the technology, a lot of times the first thing we do is just say, how can we use it? Or sorry, what can it do? But not how do we integrate it with the human? And there was definitely some human interface challenges with the whole thing. Right now, as Jeremy said, I'm the Canadian Armed Forces advisor to the AI Center. So I don't consider myself an AI expert in the sense that I'm a hardcore programmer. I've used AI, I have done some programming with it, and understand a lot of the basics. So as the AI advisor, the main task I'm working on is developing the process for acquiring artificial intelligence for all of the Department of National Defense and the Canadian Armed Forces. This is right from identification of business requirements and capability deficiencies, all the way to the development, the implementation, and then the next two steps I think we often forget about is the sustainment. We're not going to get it right the first time. And the end of life. What do we do in 10 years from now once a new AI system comes on board? What do we do with the old data? Do we just destroy it? Do we get rid of it? Do we use it for something else? The other thing I'm working on that I'm very excited is wargaming artificial intelligence. So one of the big questions we have, and again, this goes back to how do we use it, AI brings in a lot of questions and uncertainties with ethics, biases, transparency, and international law. So what I'm proposing, and I have some interest, is doing wargaming, regular scenarios, but we simulate the AI. Commanders are presented with AI decisions. I put that in quote because we don't need actual AI. We can have subject matter experts act as the AI. How do commanders use that? Have we violated any international humanitarian laws through the use of AI? And start developing our SOPs and doctrine. So I'm very excited to see where we go with this. I've also worked with Defense Research and Development Canada on a number of human factors initiatives, including the Tiger, testbed for integrated ground control system experimentation and research. This is where we're able to reconfigure the ground control station to try to find the optimal configuration. So really exciting with that. And I've also helped with co-wrote the article on the impacts, a trust model for human autonomy teaming. What impacts was basically a rules of engagement confirmation. So as a UAV pilot, if you're about to engage a target, the impact system would go through the authority pathway, as we call it, to make sure that all the conditions were met for engagements. And again, designing it with the human in mind to provide that backup, that reassurance that you do have that authority, you haven't missed any steps. Very much about how we integrate the human with the technology. So, as I'm not busy enough, I decided to do a PhD. Currently doing this at the University of Toronto Institute of Aerospace Studies. And the proposed thesis topic is Human Artificial Intelligence Teaming, Measuring AI's Trust in the Student Pilot. There's a lot of research right now on how do humans trust AI. But I haven't found any research that really got into how does an AI trust a human? Humans are fallible. We make mistakes. In aviation, there are many examples of accidents where a new pilot is still learning, makes some mistakes. Or physiological. There's been accidents because of fatigue, tired, or they're focused on something else. And we also have, unfortunately, those rare few pilots who use the system, use the aircraft in a way it was not designed to do, and therefore have put it into a dangerous flight profile that resulted in a crash and death. Can AI measure their performance and say, I do trust you to fly effectively and efficiently, and I trust, well, I'm not trusting anymore. I don't think you can fly safely and effectively. So I'm very excited to see what we can do with that research, because when we talk about trust, it's a very, very challenging topic with that. I've also had the chance to co-author a paper with Jeremy on trust dynamics and human autonomy teaming. So as you can see, a lot of my focus, as I said, I'm not so much as an AI expert, but I've done a lot of work with the human factors. And that's what I'm hoping to talk with all of you today about, is that integration of, again, not what does the technology do, but how we use it. Thank you.
Ten years ago, AFRL was visionary. We predicted the future need, and we created the concept of affordable NAS. And we did the foundational work at AFRL to make a CCA program of record possible. While I've been fortunate enough to participate and lead in some of those foundational efforts over the last 10 years, today and recently I've been assigned as portfolio lead for Autonomous Collaborative Platforms, or ACP, in AFRL. And so I'm proud to stand in front of you today and present this information. So when I say ACP, what do I mean? First thing, autonomous. These are unmanned or uncrewed aircraft systems that are primarily controlled on their own with autonomy or AI. Collaborative, so they're designed to be to work together with unmanned or uncrewed and with other crewed assets. So that brings into data links and open architectures and facilitating collaboration that way. When you combine that with the information that I'm showing on the right-hand side, where we have sort of a cost spectrum and a use spectrum and a maintenance and maybe an attrition tolerance or loss tolerance spectrum, where we kind of sit in between expendable and on the left-hand side and exquisite on the right-hand side. We can explore that space and give a capability to give us the ability to achieve affordable and flexible mass with, as you look at this concept across different missions, with unpredictability. And then when you couple this with an operating construct where we're looking to minimize the logistics and sustainment footprint, that's where we have a really powerful concept here. And we're really excited about this, this ACP concept. And so as portfolio lead, I'm coordinating and leading technology development across the AFRL technology space, or the different technical directorates. Well, I'm a part of the Aerospace Systems Directorate. We cover things like the airframe, system integration, autonomy, power and thermal, and propulsion. We also have different technical directorates that we're coordinating with to build out the entire weapon system, that are things like human effectiveness, sensors, information, materials and manufacturing, and munitions. So that's a little bit about the ACP portfolio and what ACPs mean to us. I'm going to skip through a few here. In reviewing this presentation over the last week or so, I realized that I'd like to tell the story a little bit differently, so I'm going to kind of skip to the end here. Like to DJ as a side hobby of mine, so we're going to mix it up a little bit here and show a historical roadmap, and this is copied pretty much directly out of charts that that came from about 10 years ago or 11 years ago, 2014. I promise you that I actually copied this and pasted it in directly. You can tell by the builds that I wouldn't usually use here. So I'll build this up here, and a few things that I want to show to you and bring to your attention. First, we started this in 2014. This roadmap starts in fiscal year 15, so October of 2014. Second, the approach of spiral vehicle development or generations as we go through and mature technology to a certain point, then we go out and build systems to demonstrate that. And at the same time, we're doing technology maturation efforts that that feed into the next spiral of design. The other thing that I want to bring to your attention is this big bang on the right side, the star for the program of record transition. We predicted that that would come in fiscal year 23. So now I'm going to go back a few here. Build back, sorry, rewind. And show you where we're at today with our current state of ACP air vehicle evolution. So you can see that we started off with design efforts. These were some things that I was a part of in the early days that fed into this generational or incremental vehicle system development. The first generation was about answering the question, can we produce a vehicle that's relevant quickly and cheaply? And that was the program called LCASD, or Low Cost Attritable Strike Demonstrator, that resulted in the XQ-58 vehicle that we developed with our industry partner Kratos. And I also want to bring up that on the top there is where we're showing some first indications of user pull. And it was really tech push up until that point. So in the 2020 timeframe was where we first started to see some indications of real demand. With adversary air operational concept from Air Combat Command, with a rapid prototyping requirements document for adversary air, and then a strategic requirements document for ACP from Headquarters Air Force A5. And then, of course, culminating with the big bang, the Secretary of the Air Force announcing the CCA program in 2023. So we pretty much nailed it. Generation 2, so we've been developing these generational or incremental cycles here. Generation 2 was about answering the question, can we leverage commercial industry best practices to make aircraft more like a commodity? That we pursued with a program called LCAPS, or Low Cost Attritable Aircraft Platform Sharing. We originally had many industry partners, Aurora, Boeing, Lockheed, Northrop Grumman, General Atomics, and Kratos. Eventually, we built out one of the platform sharing concepts that we called OBSS, or Offboard Sensor Station. The vehicle designation is XQ-67A. And I was fortunate enough to be the program manager on that effort. Along with the other Generation 2 effort, which was aimed at answering the question, can we design and achieve fighter-like performance with the ACP class of aircraft, a program that we called Bandit that was addressed towards meeting adversary air needs, that we worked with a company called Blue Force Technologies. And we have Scar here today from Blue Force, formerly Blue Force, now from Anduril Industries. And the thing that I'm most proud to share with you here is this direct transition into the CCA Increment 1. General Atomics and Anduril Industries both leveraged heavily the work that they had done with us under this second generation and over the last 10 years, really, building up the technology to be ready to transition into Increment 1. Where we're looking to go in the future is a third generation with advanced capabilities. Can we push even farther in terms of performance to shorter runways, higher speed, higher turn rate, better acceleration? Can we integrate weapons better? Can we do aerial refueling with this class of aircraft that we see as feeding into future increments and other ACP applications? So I'm kind of running out of time here. I'm going to hit real quickly on recent accomplishments. Got to give a shout out to the ACP team here, the teams that are working on these activities. So first off, the demonstration of ACP Performance and Effectiveness Program, also known as DEMONAPE. You can imagine how much fun we've had with creating AI art and logos and patches for this program. We completed flights just a couple months ago in May with the XQ-67A in a new configuration, and it was demonstrating autonomy, mission computing, data links, and power and thermal management and networking. So this foundational mission systems backbone that we can then build on to do more complex behaviors, more complex autonomy and mission systems. This improves our knowledge and our understanding of the integration challenges and how to overcome them. And it really is assessing our ability to predict the performance of an integrated system. The last thing that I'll mention here is Autonomy Industry Days. So we did this also in May. It was a busy month for the ACP team. So we want to announce this and continue to bring this to industry's attention that we're actively seeking partners for autonomy solutions to deliver this decisive and asymmetric advantage. And within the ACP domain, we're focused on things like contingency management, terminal area operations, and autonomous teaming. So those are some recent accomplishments. Like I said, over the last 10 years, we've done some great work in this area, excited to share that with you today and talk about a little bit about where we're going in the future here. Thank you.
All right, good morning, everybody. I'm Lieutenant Colonel Taylor. I go by Growl Wilson as the commander of the 40th Flight Test Squadron down at Eglin Air Force Base. I'm here to share with you the quick strategic shift that our traditionally legacy 4th gen flight test developmental squadron is now taking after looking at the new autonomy directives and next gen vision. So I'll share a little bit of our autonomous collaborative platform development process. I'll give you the what, the how, and a little bit of the why. So starting off, all of the Air Force test centers, the 96th Test Wing, and specifically down to the 40th Flight Test is built off of the shoulders of giants here. Starting all the way back almost 10 years ago with some of the AFRL Skyborg programs and the buildup and risk reduction towards AI, agent-controlled flight, whether it be platform or mission autonomy. Those were also capped off in 21 and 22 over at the United States Air Force Test Pilot School, working on manned, human-on-the-loop test beds with the Learjet as well as the X-62A Vista aircraft. And then as we transitioned here over the past few years, starting in 2023, some of the first flights of our Group 5 UAV, UAS combat aircraft in the XQ-58 Valkyrie system. Back as well, integrating into a large force engagement during Emerald Flag, where we demonstrated live EW AI agent controlled activities, as well as data link message sharing all the way back to the warfighter in operationally representative systems, as well as back in May 16th of this year, we demonstrated live dual agent controlled autonomy, executing on dual Q-58 platforms, quarterbacked by manned F-16C as well as F-15E tactical platforms. All of this developmental process is being fleshed out here down at Eglin Air Force Base, starting from the software buildups where you have a large scale of data trying to crank through the hard problems. And then building out that digital test environment where we can actually put crude testbed surrogates and put them through the paces. We have everything ranging from Group 1, small quadcopters with our sister squadrons there at Eglin Air Force Base within the 96th Test Wing, all the way up to our Group 5 UASs that we talk about here that are owned and operated and executed with mission partners as well as the Defense Industrial Base for the requirements and capabilities development. All of it is now new headway as we transition into a new pipeline for the Viper experimental next-gen operations model for F-16s of turning into a tactical platform into a next-gen autonomy test bed. And I'll share with that. All of it feeds into the long-range operational capability that we are going to transition over the coming years. The big picture, we are focusing on agent evaluation, using our test beds in the developmental space for research and design, as well as building out that integration proving ground right there on the coast. This is effectively your field of dreams. This is hundreds of millions of dollars of investment across the Air Force Test Center, leveraging all of our partners to put together high fidelity range infrastructure for RF data links to control these autonomy test beds and platforms all the way out over the coast, connecting them back into the test mission controls to monitor real-time safety of flight parameters and make sure all the execution is running smoothly. There's lots of lightning bolts. That's the standard in an Air Force presentation. However, what I'll say is all of those carry massive data streams, and that data fidelity and that friction is something we're continuing to hone in on to focus on safe, secure, effective, and efficient flight test. A lot of it, specifically down at the 40th flight test, is our new investments into our digital test environment, or as we term it in our acronym, TADTE facility, where we are actually executing and will be executing over the next programs of records some of that real-time agent evaluations as well as faster than real-time autonomy evaluations so that we can prove out and compare and verify, validate all of the capabilities that are flying in real time in either live mission, live virtual, constructive, or anything in between. Going specifically into our resources and capabilities that we are basically taking that shift from those 4th-gen platforms, from your F-16 developmental test, as well as your F-15E and EX. We have 2 XQ-58 Valkyrie platforms that we have been putting through the paces for the past several years. Obviously, this is all distro A. It was very challenging to hit some of the new images and get them pumped into this. But trust me, all of this capability has been multiplied many-fold to demonstrate multi-ship autonomy and execution in real time with human agents. The big thing is safety, everything from the control room to the humans on the loop, making sure that we have all of the closures of those loops to ensure that nothing is unsafe, and we are effectively burning down every single test objective that we can. As we take the shift, we've recently accepted the transfer of 4 developmental tests as well as 2 operational test F-16C models in support of the DARPA Viper Experimental Next-Gen Operations Model, where we are taking what were previously tactical and combat-coded aircraft and putting them fully instrumented, ready to execute on the range with live agents executing, including that human that's still sitting inside the cockpit on the loop, ready to take command at any moment. These are going to be built out as autonomous flying test beds, leveraging all of the models, all of the awareness that we know and love out of the F-16 that has been purely vetted, everything from platform flight sciences to the actual mission systems, and integrating those into those models and replicating them in that digital lab environment so that we know how to evaluate which agent is working, how it's working, and how it's making decisions. That how is very, very difficult, I'll say, and we are continuing to build out that framework for how do we evaluate that dual nature of AI testing. Historically, in a developmental test squadron, we talk about data. It's very quantifiable, it's very tangible, it's very real, but as soon as you introduce something like a deep reinforcement learning or any other advanced agent here, the real how and the why gets very complex. And it is very difficult to evaluate those performances. And so it turns into almost a qualitative measure that you have to place on top of the traditional validation verification steps for integration and ensuring runtime assurance features. Explaining this more of the how goes into the tactical debriefing. After we set up the sortie, we put the system through all of its paces, monitoring real-time execution in that control room. It comes back to the data. It comes back to the debrief. And that AI explainability is very, very difficult, especially with less mature deep reinforcement learning algorithms, because in those quarterback scenarios where you have crewed and uncrewed teaming scenarios, you can't sit that human down in the face and look at them and ask the question, why did you make certain decision? Unless you've run through tens of thousands of different models and simulations and rehearsals and have something one-to-one almost to compare against to ensure that we are doing the predict, test, and validate steps. In closing, the 40th Flight Tests, in concert with all of the Air Force Test Center's investments with our mission partners and contractor teams, are continuing to advance this surrogate testing to build out lower risk and transfer lessons learned to future programs of record. Thanks for your time. I'm excited for your questions.
My only slide. Hi, Sean O'Brien. I've been working in advanced algorithms, AI, and autonomy for decades now. And that's a good lead-in because explainability is a tough problem. I'm going to broaden it out a little bit. Talk about bounding the behavior of these kinds of systems. How do we just fundamentally predict and bound what they're going to do? We need to be able to do that if we're going to engineer them and then use them and field them. It's a hard problem. We're familiar, if you've used a chatbot, you're probably familiar with this problem, right? it's difficult to bound the behavior of something that's fundamentally non-deterministic. Okay? I have a friend who went to work in an environment in the government that was transitioning to using AI in their software labs. And she called me a couple months in and said, my software testers don't know how to do their jobs anymore. Because they're used to taking data, shoving it through the system, and then looking for errors, and then using those errors to, find bugs and things like that. And if there had been no updates to the code, then they would expect no change. But then sometimes they would find no updates to the code, but now there are new things cropping up, changes of behavior. How do you deal with that? And it's not just a problem for AI. It's a problem like in the world of autonomy. It's a problem when you just go to open world environments. And even if you're using control theory, even if you're using, nominally deterministic algorithms, it can be very hard to predict the behavior of the system in an open world environment where basically you're dealing with novelty situations that the system has never encountered before. How do you test that? Right? And so we need new ways to test. We can't test it the way we've tested previous systems because in autonomy, we're asking the systems to do things that we've never asked systems to do before. Well, not quite true. The systems we used before were human beings. Okay. Now, the systems are a complex chemistry of hardware, software, and wetware. Okay. And we can't just give them the same tests, right? There's been a lot made of the fact that recently, some of the chatbots have been able to pass, the law exam, the bar exam, the medical exams, the SAT tests. They're really good at that. Okay. That doesn't necessarily mean that AI is going to be a good lawyer or a good doctor. Because there are lots of things when you give a human that test, you're giving them credit for a whole bunch of stuff that the AI doesn't necessarily know how to do. When my son took his driving test when he turned 16, they didn't test whether or not he understood object permanence. That when a car disappeared around a corner, it was still there, even though he couldn't see it. AI doesn't necessarily have that capability. Autonomous systems don't necessarily have that capability unless you test specifically for it. Okay, so testing is hard. And we need new kinds of test regimes. We need to test the whole system, the hardware, the software, the wetware, together to make sure that they're going to be effective in the mission. If we're going to have affordable mass, we need those tests to be rapid, easily accessible, affordable. We need to be able to get the algorithm people and their algorithms into the air as quickly as possible and then iterate as rapidly as possible so that we can learn how to do this stuff, how to bound the behavior of these systems. It's a little like the situation in computer programming in the 1960s when software faced a crisis. People would build these computers and they would try to test them and they were failing and the systems were taking 10 times longer than they thought to develop because they didn't know how to test them, because what they had been doing is testing the computer, because building the hardware was the main task and the programming was just part of that. And what they figured out is they needed to abstract away the software from the hardware in order to test it effectively, and hence the field of software engineering was born. We need autonomy engineering like that, where we can test these things quickly and effectively. So what we're looking at here in this picture is the tail of the Beacon aircraft that Northrop Grumman built on its own dime. We built this entirely on our own funding in order to attack that problem. It's not intended to create, our own vertically integrated closed garden. Right? It's intended to create a system that the industry itself can use. That people can bring their autonomy software, their autonomy systems to us, and we will help them test it, integrate it, quickly test it, get it into the air, see where it fails, see where it works, figure out where the boundaries of its behavior are, okay? And do that quickly and cheaply. Right? So it's not just the big guys with lots of VC funding and things like that who can do this, that we can have little tiny companies, academia, whoever wants to bring their algorithms And they have access to an inexpensive test platform where they can get their algorithms into the air, into the open world environment, so they can test these things. I'm really excited about this because this is really important. If we can't test quickly and effectively and learn how to test, right? Because that's a big part of it too, is learning how to test these things effectively, then we're not going, the pace of our advance is not going to be as fast as we'd like. So that's the big message I wanted to bring today. That's what excites me about the time we live in right now. We're at the birth of, I think, a new kind of engineering, the engineering of autonomous systems, which are different from the systems that came before. Okay. Whether you're talking about robots or self-driving cars or autonomous airplanes, these things are doing different things than have ever been done before. They require different kinds of engineering approaches. I mean, also a lot of the same approaches, but new approaches added too, new kinds of testing, and new platforms to help us figure that out as quickly and efficiently as possible. Okay. So I can't wait to see where we go from here, and thank you very much for your time.
Good morning. We're actually going to start with a video.
All right.
At Lockheed Martin, we see things differently. We look for innovation and see how it can move the world. Because our mission means more than just protecting tomorrow. It's about propelling it forward. So we use the power of data to build powerful connections. Utilize AI to bring our technology to the fight.
Wildfire contained.
And look for answers in places others would never think of. Beyond what's possible, we go past that every day.
The journey to Mars has begun.
Take a closer look at Lockheed Martin, and you'll find a team of innovators that see things from a different point of view. But our mission is always clear.
All right, thanks. So I do not have slides today. Why put up slides and talk through things when I can provide you cool airplanes to look at and other things in the video there. So thanks for having me today. I look forward to the engagement that we're going to have coming up here a little bit later. But what I just wanted to share here, and I'm going to train for mission, not for time right now, is it is an exceptionally exciting time in industry, and then looking at this from my former life as a warfighter in combat air, because we have now the collision of CCAs, some affordable platforms that can do a broad spectrum of missions. We tend to be focused on the air dominance mission because that's what CCA Increment 1 is focused on, but these collaborative autonomous platforms can do ISR, they can do air to surface, and in the commercial industry, they can assist in firefighting, things like that. So that side of the transformation is exciting, but bringing autonomy and AI is really what realizes the capability of these types of platforms. In my former life, the challenge of the remotely piloted vehicle was you had the advantage of a product that doesn't require a pilot in the air. But if you look at the tail that was associated with that platform and the way that you needed to operate it, you really did not see any significant savings when compared to a manned platform. Now with bringing autonomy and AI into a flying platform, now you can achieve the vision that those platforms were always predicted to provide. So on the CCA side of the house, I come from the Skunk Works. We've been known for a long time as innovators. We have collaborated with our customers for decades now, providing what my boss, O.J. Sanchez, likes to refer to as drones to the warfighter. Most of those platforms that we've developed and fielded have been classified. And therefore, Lockheed Martin isn't necessarily widely known as a drone company. But the reality is all the way at the low end with small UASs designed to support three-letter agencies and special operators, all the way up to large platforms, operating in support of our nation's missions. We've been there. The challenge is we tend to follow Kelly Johnson's rules inside our house, which means that we had cylinders of excellence inside our organization that meant that we had great things that came from platforms and great things going on in the spectrum of autonomy, but we weren't cross-talking amongst ourselves. The advent of the CCA programs and the pressure that comes from some of our disruptive competitors has forced us in a very positive way to change. So now we are deeply engaged in bringing AI to our design processes. How do we not replace the engineer, but how do we take some of the talented engineers, of which we have a few sitting here in the front, and make them more powerful by using AI agents for the repetitive work that an AI agent may be most capable of doing today? How do we bring those AI products into an autonomy, mission autonomy software product that you can deploy on multiple platforms? Doesn't have to be built by Lockheed Martin. We can collaborate with our partners across industry to bring best of breed capabilities into a platform that the warfighter needs. And then finally, as we look at going forward, this has also sparked collaboration across our industry. I can tell you from my past history as the requirements lead at Headquarters Marine Corps, the idea that you would take 15 or 16 competitors, assemble them into a consortium, and then get them to agree on a common architecture about how we do autonomy, about how we field mission systems to the fleet, that was not possible 10 years ago. Today it is. So I'm going to close with saying it's an exciting time to be part of what we are doing. I'm looking forward to the conversation we're going to have up here, and thank you very much for your time today.
Morning, everybody. My name is Andrew Van Timmeren. I go by SCAR, and I'm here representing Anduril Industries. By a show of hands, how many people have heard of Anduril Industries? You guys mind sharing? So just super quick, as a level set here, the company was founded back in 2017 with the ultimate goal of bringing modern software practices, principally leveraging advanced autonomy, into the capabilities that our operators use every single day. So fast forward to now, from 2017 founding with a handful of folks, all the way to summer of 25, growing up to north of 6,000 people and more by the end of this year. We have things operating in all domains. But what I really want to get after here are a couple of things, and I'm the last thing on stage before we get into the really fun part, which is the actual discussion, is the importance of leveraging this autonomy for the augmentation of the use cases and our operators that are already out there. Autonomy and autonomous systems are intended to overall achieve operational outcomes. They are not intended to replace or make the importance of the gray matter, your brain in the decision making. It can assist and augment in support, but we certainly feel like the ability to make humans better in the things that they do is one of the key things that autonomy has to offer. I think we also have a lot to learn, and as Anduril, as was said, is on the CCA program, and the whole point of this is to discuss the injection of autonomy into aircraft, et cetera. But there is still a lot of learning to be had, and I think that's what's exciting. I think here in 2025 we are in a really important time where there is a lot of learning, a lot of disruption, maybe a lot of challenges. We are going to fail in certain regards. One of my favorite stories is we are leveraging computer vision in our tower, and it was scanning. We were trying to teach it against video and images, and it put a bounding box around a cow, and it had 100%. That's a horse. And so there's a lot that we still have to learn. There's a lot that we still have to develop, and the importance of getting things fielded as quickly as possible so that we can get after that learning cannot be understated. So thank you guys so much for listening. Thank you for AIAA for having us, and I look forward to the conversation.
Okay, that was a pretty stellar set of introductory presentations, and the Q&A is very lively. I'm going to start out with a few intro questions just to help set the context a little bit more, and then I'll flip over to the audience side and basically scrap all the questions I prepared because you guys have done a pretty good job. So I want to start out by framing this discussion. Like a lot of the stuff that we've been talking about here is about collaborative autonomy, not just autonomy. I want to first set some definitions here. So how would you define collaborative autonomy? How does it differ from autonomy on its own? How does it differ from swarming or previous cases where we've seen aircraft, sort of quote unquote working together? And this is an open question. Whoever wants to take that one.
I'll start anyway. I see collaborative autonomy as where the function of the system is really the combination of the functions of individual parts, and that could be a human or a machine or both. And so the collaboration, so like in a swarm, for instance, you could have that be collaborative autonomy where you have systems that are collaborating with each other and then also with the humans. But the most important aspect of it is two-way, right? It's not just a person tasking an autonomous system and then walking away or letting it do what it's going to do. It's that two-way. And as was pointed out earlier, there has not been as much attention, in the past to, the computer understanding the human, right? That's a big part of it, okay? And again, I get back to my son taking his driving test. We didn't test him on how well he could, understand what other drivers were likely to do. Because we know he knows how to do that because he's a person, right? Machines don't necessarily know how to do that. We need to help them understand the human. And that might have to do with just the way that, better understanding the context of the human commands. It might have to do with, having sensors that tell you, oh, that person's fatigued or maybe I'm overloading him with information, right? So in order for it to be effective autonomy, you don't want the autonomous system during a critical time where the human's doing a lot of stuff to suddenly overload them with a bunch of information, right? So collaboration is solving those kinds of problems. So that's how I see it.
Okay, so that element of, I guess, independent decision-making together with cooperation, the sort of mutual understanding and context.
Mutual understanding is really important.
Okay, anybody else want to weigh in?
I'll just say on that, yeah, absolutely. I know Defense Research and Development Canada has, and one of my PhD advisors actually has been working a lot on intelligent adaptive interfaces with that idea as well, where the automation is able to measure the workload, the task saturation. And it's about, one, presenting the right information in the right time in the right way, but also taking over functions and allowing the human to do their job. When we talk about the cooperation, the collaboration, I think this is one of the things that's really powerful about AI is the fact that it can start, one, supporting the human pilot or the human operator. But we've already talked a little bit about explainability and that idea of trust. And we look at it, and one of the big things with automation for the human is predictability. Can it predict what the AI is going to do? This is where it's really unique that now we have a tool that I believe can predict what the human is going to do. So as an Aurora crew member, I always remember posting season, we get new members on the crew, and the first couple of flights were always a little rough. We're stepping on each other on the intercom, trying to figure out how everybody else is going to react. But after a couple flights, we really mesh as a team. We're able to predict how and when other people are going to respond. And with the collaboration, I believe that's the other side of it too, is looking at how is AI going to react to the human? How is it going to understand, predict what they're going to do, anticipate their needs, and work together to support. So again, yeah, it's exciting with the technology and what we can do. Some big challenges, because now we're getting away from just the software engineering side and actually getting into psychology of some of these things as well.
I really appreciate that perspective on like forming, storming, norming, and performing. When you first create a new team, same thing's kind of happening in the human autonomy teaming context. You guys already touched on it in terms of the role of AI here, but I do want to ask it just for completeness. Do you see AI as being necessary for achieving collaborative autonomy? Right? Like We have various kinds of automation available, various kinds of platform sizes available. Is AI needed? Or is it one of several tools to enable autonomy or collaborative autonomy? Where does it make sense to use AI versus not?
I'll lead off with that. So I think one of the things about AI that it can come up with better solutions in novel scenarios than maybe humans could come up with. I think we've seen that. One of the most public examples over the last 5 years of a program that has demonstrated air domain agents coming up with novel behavior in scenarios that humans find themselves would be the DARPA ACE program. And that's been leveraged by the VISTA in Air Force Test Pilot School and others. And it shows that we as humans may not know the full pantheon of decision-making within a particular scenario. But I also think that has to be limited in when it is used, because I'll just give you a great example. When you're flying through FAA-controlled airspace, they really don't want you to be thinking. They don't want you to be like, well, I think I should just change my altitude right now as you're on approach into Atlanta. You are on a prescriptive route. You are on in executing procedures that are well understood, and that is actually for the safety of you and everybody else around you. So there are times and use cases where you might want to go a little bit more free with like edge autonomy, but there are also use cases where it is not the right answer. It's like saying I need to use a screwdriver as the only thing I use when I build a house. It is a tool to be used at the appropriate time, and it is a tool to not be used when it is not appropriate. I think that's okay.
As a technologist, I can't tell you how many times someone has come up to me and said, can you give me an AI solution to this problem? Hold on. What's your problem? And let's figure out what the right tools are, right? And you can do a lot with traditional control theory and things like that, autonomy. And so I think it's really not a matter of do we need AI? It's how do we incorporate it effectively, and where do we need it in which parts of the mission?
I think about the applications of autonomy and specifically AI, and I think about the scenarios where we need to really isolate down how to drive down the workload in the cockpit for the aircrew, and obviously, we deploy, we engage as like systems teams, large teams, and that isolation and refinement of that objective really matters because otherwise it's just the buzzword. I think about EW spectrum warfare. I think about the rules of thumbs that folks are using inside the tactical environments, and those rules of thumb quickly go out the window when it comes into novel, like next-gen, future threat environments where we are seeing things from a human perspective that we've never seen before, or we're seeing new threat space and multi-domain fires and effects where we aren't able to leverage our human brain locked and limited perspective versus maybe like the AI driven like backends that have maybe seen something similar that can quantify a risk scenario and help make those decisions.
Okay, fantastic. I appreciate that. I'm going to switch over to the audience questions now. So again, open question for whoever wants to jump in. But how do you foresee legacy crewed and uncrewed aircraft with minimal autonomous capabilities integrating into an increasingly connected fighting force? So I guess as the fleet itself continues to change, we're bringing on these new CCAs, new capabilities. How do you see the role of the human? You talked about, Lieutenant Colonel Wilson, you talked about AI and these capabilities supplementing the human or complementing the human. How do you see that integration evolving over time, that force structure?
Jeremy, that's a great question, and it's one that we tackle every day inside Element Aeronautics because we have a portfolio of platforms that were designed in a different era, continue to provide value to the warfighter, continue to be modified and upgraded to compete with a modern threat. With that said, how do we now have them collaborate and operate within these new system environments? I think there's a couple of key elements that go to tackling that problem. One is iterative development. Trying to come up with the gold-plated solution that I'm going to go place, going back to my former life, in an FA-18 cockpit that is going to, in some way, enable an FA-18 pilot to be more effective in their mission is going to take, in old school Pentagon terms, 10 years, $10 billion, and will be 50% over budget. And that's not just because Lockheed Martin did it. The reality is rapid iterative development is the way that you tackle that. Two, the fact that we have embraced open systems architectures and transition to service-oriented architectures as we develop our algorithmic and software solutions means that we are able to take what traditionally in a legacy platform is kind of a whole system enclave, a bunch of spaghetti code that it's very difficult to unwind. You can create an open systems architecture enclave in there and then bring new capability to that platform without disrupting the whole system.
Okay, so that bias towards iterative development and testing is key for you, and that I guess that open systems architecture where you still have, like you said, an enclave, some of it's preserved, but you still have opportunity to interface and collaborate is key. Anybody else want to?
I'll just mention that just building on what was just said, this idea that no one person, company, organization has the answers here, so that open iterative architecture is extremely important. Being able to bring in new ideas quickly and get them into the system, right, without having to go through 4 layers of acquisition, and contractor, contractors, to be able to just, hey, we've got a new idea, let's go test it, let's get it in the field and get it helping the operators and the pilots.
So I guess with all this talk around testing then, so we've got a few questions from the audience. I'm going to try and consolidate it into one question here. But given that AI is a relatively new technology to aviation, a lot of the work being done so far is of an experimental nature, not necessarily being done at scale yet. What progress has been made on airworthiness approaches and verification validation approaches for AI? How are each of you perhaps incorporating that into your programs, or how do you see this evolving moving forward?
Yeah, honestly, for the Canadian Air Force, this is a very new area. So we haven't incorporated AI into the airworthiness. And AI is still very, very new when it comes to the work that we're doing here. And we do have some rather robust software engineering processes. And so, as I said, I was liaison for the software engineering squadron. And working with that does bring some good experience. But this is where, when we talk about software and AI with it too, it is such a unique and challenging entity. So in addition to doing operational test and evaluation, I was the chair and I taught operational test and evaluation and the software engineering for it, for the Air Force for a few years. And one of the things I always did was just highlight to the students just how different software is. So I'd give a question, we'd have pilots, and I would say, could you explain to me your fuel system in your aircraft? And they could give a fairly good description of that fuel system. And then I'd say, okay, great. Could you explain to me the algorithms of how the GPS is able to calculate your current position? And of course, very, very complex. They couldn't, even though they use GPS all the time. So for us to understand and put wrap our minds around how that AI is working compared to adding a new component, a hardware component on the aircraft is challenging. And so the big thing I think we need is people such as myself in that role as the liaison who understand both the operator's needs but can speak a bit of language with the software engineers to be able to help that process in the airworthiness. So that when the engineers, and I worked with some brilliant people, including one that worked on the Canadian Space Arm, didn't know the first thing about how we did operations. And why would he? He is an expert in what he does. And likewise, I worked with some brilliant operators. And yet I would have them, I remember one time one individual came to me and said, we should install this new component on the aircraft. I looked into it, it's AirInc 429 compatible, so it's plug and play. Well, that's not how that works. So I think that's the role, is really having those liaisons to explain those as the challenge goes forward.
Yeah.
So the first point I'd like to make is that for pretty much any UAS, and especially the ACP demos that we've done, airworthiness risk is assessed as high. I don't think that it's going to be assessed as anything lower than high because unless we tailor or create some kind of new airworthiness process or criteria set to assess these against. So then that's just for the stock air vehicle, right? Then you start to integrate autonomy or AI and this unpredictability or non-deterministic aspect of it. What's higher than high, right? It makes folks in the test community very uncomfortable because we like to see things happen in a certain way, and in some aspects, in some places, it definitely has to happen that way, right? So the things that we could do to maybe lower that risk or reduce that is within the vehicle autonomy interface, right? Putting assurances or limits on what the recommendations or the suggestions, if you will, of autonomy for the vehicle to actually do, filter it out if it's going to be something that is, put the aircraft into an unsafe state or going where you maybe don't want it to do. You can put those kind of filters on it so that it still might be less than deterministic, but at least it's more safe. So that provides some assurances. I think I would definitely say that there's still a long way to go in terms of getting people more comfortable, getting the test centers, getting the overall community more comfortable with taking those kind of risks. But maybe we can get there in the future. It's definitely something that we want to continue the conversation on.
Yeah, those are really great perspectives. I kind of find it interesting when we talk about concerns about non-determinism. Like a person with their brain, in some ways, is non-deterministic, right? And what do? We apply a flight envelope, we apply bounds and constraints so that even if you don't know exactly what's going to happen next, even if you have some heuristic for predicting that, you can kind of control that. I really like that kind of operational risk acceptance aspect. Yeah.
I think, and I think that points to one of the biggest advances of the last several years in autonomy, which is not a technology per se, but it's that abstraction of, for instance, mission autonomy from flight autonomy.
Right. Yeah.
Which allows you to cordon off the behavior of potentially non-deterministic systems in the mission autonomy layer, right, from the flight autonomy layer, which is actually controlling the control surfaces, so that it acts as a buffer and says, mission autonomy wants to do something weird. It's like, nope, you can't do that, right? Choose another adventure, that sort of thing. So that abstraction, which again, going back to the great software crisis of the 60s, that was the solution there too. To abstract the software away from the hardware. In this case, we want to abstract the non-deterministic stuff away from the safety critical stuff. So.
Yep, great perspective for sure. Okay, another question here. I guess this is maybe more of a forward-looking, ethics-related question. No surprises here, but how do you see the role of autonomy playing in terms of decision-making when it comes to perhaps targeting cycles? And how do you see international humanitarian law kind of factoring into this? Is AI an enabler for that, a detractor? Any perspectives on that?
Well, I'll start off partly because I mentioned that about the war gaming. Yeah. It's a really difficult question. 2 months ago, I attended a conference in Greece on armed conflict and international crisis in the era of AI. And we had a number of panelists, both military and some individuals from the United Nations Office of Disarmament, the Group Against Killer Robots. And it was pretty good because they did provide a very grounded perspective. They weren't saying, no, stop this, but they're like, consider these points, look at these situations. And I remember 2 individuals, one said, no, AI should never be used when it comes to international humanitarian law. That's a very human application. We need the human to always be the decider. And another panelist said the opposite, that AI can enhance the protection of international humanitarian law. So with that, it was an interesting discussion, but one of the things that we noted was that while a lot of individuals, and we as the attendees, while a lot of individuals were talking about these things, we didn't see a lot of solutions to it. But this is where one of the panelists said about wargaming, tabletop exercises. And so what I'm proposing going forward with all the branches, and this definitely can apply to the Air Force as well, is doing that. And I think that's what we need to do with the ethics and the legality of it, is war game these scenarios, bring the right people in. So in addition to engaging with the Navy, Army, Air Force, and the Joint Warfare Centers, I have representatives from the JAG office on international and operational law. And so going through this, I would consider it a big success if during the wargaming, the JAG officer would stop and say, okay, because you used AI this way, you actually just violated international humanitarian law, the principality of distinction. And that way we can start looking and say, why did this happen? How can we learn and develop the operating procedures, the doctrine to avoid this? So I see that is going to be the solution. These things are such challenging areas, even for humans, that just to say, okay, I've programmed the AI and I think we're good for it. No, I think exercises, development, this is where we're really going to have to stress test the system in those ways.
Yeah, I would say in ethics, in how that applies to autonomous systems going forward, I think we do have a reasonable amount of historical data of the usage of autonomous lethal systems throughout the decades. They're called air-to-air missiles. When aircraft fly right now with autonomous little buddies on their wings every single day, and they have been used, since the 50s, 60s, and beyond. And one of the critical ways that we get after whether that system is effective or not is through the test process, through wringing it out both in simulation and in live flight. And I appreciate Growl is here as a representative of Air Force Test, because it is really important that we do conduct these operations in as relevant as environments as possible so that we can wring out what those opportunities and challenges are. But I would say one of the things that is in common in the example I said when it came to a missile, say you're flying in your Raptor, your FA-18, your Strike Eagle, and you hit that pickle button or squeeze the trigger and that missile comes off, there's human consent. There's human consent into the action of using lethal force. And I would just throw that out as a consideration as we go forward in that discussion.
Scar, to dovetail on that, one thing for consideration, it's not an answer, it's a consideration, is how do you establish the framework to determine that what you have is acceptable or not from an ethical baseline. Right now, if you look at the NTSB or you look into the EU and how they handle autonomous driving today, if you want to get a product certified as a level 3 autonomous driving application on your car, the EU right now requires that you, the car company, accepts liability for any outcome while that level 3 driving application is engaged. Drawing that as a parallel from an ethical perspective, as you're evaluating AI systems and their use in armed combat, what role should a human play, or does the human need to play in that decision making? To your point, I'm consenting by going master arm to arm and hitting the pickle button, or have I developed and tested it sufficiently that I have confidence ethically that I can take credit for the decisions that product makes, whether I am involved in the loop or not.
I always find it interesting having this discussion with sort of policy and ethically minded folks versus more the engineering folks. Because the engineering folks are basically like, you know what? We go and test it. We test it, we set requirements, we test it, we try it out and see if it works, right? Like there's a bit of an experimental mindset there, but as you said, Peter, right, like there is also a risk acceptance and a responsibility there, right? So if you are the red card holder, the target engagement authority, like you have to be willing and confident that whatever you've built is actually going to meet those requirements because you're on the hook, right? So that's, I guess, that interesting perspective to look at it from test bias and also responsibility acceptance, right?
We'll add.
yeah.
Go ahead.
Oh, I was just going to say ethics is a huge,
Yeah.
huge issue. But right now, what we're doing is, yes, absolutely stressing those operationally representative scenarios, partnering with the operational test team. What I'll share is, in the current kind of runs that we're seeing in the labs and with the performers, a lot of that is relatively basic and scripted scenarios with very clear lines of engagement and very clear directives for those autonomous agents to be executing on in the real battlefield warfare, right? There's the fog of war, there's the non-linearities, there's the what if or different scenarios such as like a defector.
Yeah.
Like how will an AI agent handle a defector aircraft that is flying towards the forward line and towards like the engagement scenario, but it has its landing gear down and it's trying to signal like I've given up, I'm not trying to engage, and I'm done with the scenario. We don't want to step into that, and I think that's where it comes into boundaries. That's where it comes into multiple rehearsal scenarios. That's where it comes into training with human supervision there as well, to see as many as we can, those kind of different scenarios.
Really interesting.
Than the basic sandboxes.
Good edge case, yeah.
Yeah, one thing I wanted to add, and this is more of not so much answering the question, but just to give everybody some extra thought on this. And I'm not saying that I agree with this viewpoint, but we talked about the human always being on the loop or in the loop, being involved somehow. And I've read some literature, they talk about the slippery slope. And the idea being is we think right now that there'll always be a human involved, but the idea being is not that tomorrow we say, you know what, let's get rid of the human. But over the course of possibly decades of use of AI in lethal autonomous systems, we slowly give the AI more and more control, a little bit more, a little bit more. And then we get to a point, as I said, decades from now probably, where we have an AI system that is operated perfectly with only a human with their finger next to the abort. And somebody finally says, you know what, we don't need that human anymore. We've never needed it in the last several years. It's worked well. So let's remove the human, and now the system is on its own. So there are those who believe that's where it's going to go. Not just, all right, we remove the human, but that slippery slope, that gradual giving the AI more and more control until somebody makes a decision, say, no more human.
Yeah, and I would just say, like, I actually really appreciate the way, Growl, that you put it. So, him and his team down at Eglin at the 40th Test Squadron are on the bleeding edge of DoD autonomy testing. And the way he just described it is we're doing very scripted scenarios. We're doing very early on or learning. And I would just say, like, to level set for everybody in the room, everybody's listening online or will listen to this in the future, Skynet is not here. Like, mind controlling robots are not around the corner. And we are not, like, we're not even in like the crawl of the crawl walk run. We are in like the discussion on a panel of this. And so I think we have some high TRL applications of machine learning, like I mentioned, computer vision, or other places where there is fielded utility of machine learning and artificial intelligence. When it comes to in the air domain, I don't know if anybody's actually seen the movie from 2005, Stealth. Has anybody seen that movie? About an unmanned fighter that's goes crazy. It's a terrible movie. You should watch it. And we are not even freaking close, right? We should just make sure everybody understands, like, we've got a long way to go to get to that slippery slope. It's exciting to be here, and we are no doubt in the ground floor, and I encourage everybody to get involved in the ground floor. But you can keep your tinfoil, in cooking, because it doesn't need to go on your head just yet.
Thank you. I really appreciate that balance of perspective. Nice. Switching gears a little bit, just based on the audience questions here. So I guess as we continue to get to that crawl stage or go from crawl to walk maybe eventually, how do you think about the financial responsibilities and like risk sharing between government and industry as we move forward? Like all of this is contingent on a really tightly integrated military industrial complex. Some of that risk has to be shared. As we're making these decision cycles much faster, you talked about iterative development, moving at the speed of relevance comes up very often. How much of that financial responsibility should be on industry to sort of take some of these risks versus the government and perhaps the taxpayer?
Yeah, I'll go ahead. So it's fairly clear cut in terms of how we would define it within Air Force or Air Force Research Lab. Like if the government is investing any dollars in it, right, we have to take some responsibility or some, I guess, inferred liability, right? And so then the additional rigor comes, and the test approval or the test review process comes in, and we have to make sure that we've checked all the boxes and reviewed everything, that it's definitely going to be safe. But there are situations, I think, where it's not 100% government investment. Maybe it's the other side, right? It's 100% industry investment. Then the rules go out the window, and industry can do whatever they want to. I think in the future, right, they're probably doing these activities because they want to get into the game on a government program in the future, right? And so you have to think with that end state in mind, and go towards that direction. So I don't think it's a complete free-for-all ever. I think there's always going to be some rigor that goes into the process. Industry doesn't want to have negative events happen and egg on their face, that kind of thing. So that's my perspective on it.
I will say that as our companies invest, things like Beacon and a lot of the other things going on, the government has been very supportive of those investments, of us, bringing stuff to the game, right? They want to see the new ideas, they want to see the new capabilities, and I think everyone's very excited. There's a place for government investment. There's always been a place for private investment, and Northrop has been investing in autonomy, for many, many years, and continue to do so. And like, for instance, with the Beacon aircraft, it's intended to help everyone with this, right? To help the field move forward, to help the government move forward, and obviously we're not doing it just to throw money away. We think that there's a purpose for this and that it's going to help us and everybody else. But it's intended to, again, move the mission forward, right? None of us are in this because, we just want a paycheck, right? We're all in this because we believe in the mission. We believe in, national security is an important thing, and that's why we're all doing this. And that's why I'm excited to, be part of it.
I'll just say, what a question to kind of divide the industry, and just to throw that out there. What I'll say is at Eglin, what we are really focused in on is defining who's the ownership of the platform, who's the ownership of the overall program, and where those investment dollars come in, especially when you have technical risk acceptance and potential like payload losses is a reality on some of these very, very low cost, very small systems and localized effects. And what I'll say is the Eglin test and training range in our infrastructure buildup, we are very much focused on that multi-domain autonomy solutions, both on the ground, air, space, et cetera. And yes, what I just shared with you guys is very much, aviation, air, and some of the glossy brochure like fighter applications. However, there's many different layers within everything from defining, threats and environment like characterizations for like airborne and like spaceborne systems, relaying that back to the ground to a new decision node to feed warfighters. What I'll say to kind of answer your question is all of that comes off of the warfighter requirements, and those start at the very top, and that's what was referenced from some of the A4L slides and showcase. It is absolutely the prime starter that drives that signal to the industrial base to advance new and novel capabilities and look for new applications.
Jeremy, I'll tell you, so let me frame this, that my answer is going to be probably not the thing that makes me want to get up and go to work every morning, because I love working with our teams. I like working with our team to deliver capability to the warfighter. But on the business side of the house, that is where you talk about what are the responsibilities there and what's the proper risk or cost share, if you will. Some of this comes to the change in acquisition approaches that we are now seeing evolve over the last, I'll call it 6 years or so, both from a DoD perspective and with some of the disruptive new entrants, into the defense industry. The reality is, for a company like ours, we do invest. To Sean's point, we put good money behind developing capabilities either that have been asked for or that we know that there is going to be a market for in the future. But again, the part that I don't necessarily wake up looking forward to every morning, that means I have to go fight for those funds from the business, and I need to prove out a business case that says that the company's going to get a return on that investment. Right. Some of that, though, is driven by the muscle memory that the corporation has based on past acquisition practices. The fact that we are changing the way that we acquire products within the DoD means that some of that old muscle memory is no longer relevant, and we have to retrain. It's the whole iterative design and delivery of capability is different than it was 10 years ago. And so we are adapting to accommodate that and recognize that we now have to come with a product to be competitive instead of putting a proposal forward and waiting for the government to fund all the development.
Yeah, for sure.
Make an update to my. I don't want my comments to come across as making it seem like if the government wasn't involved, then industry would take all kinds of risk. I think, in fact, as we've gone through this process of the start of the LCAT or Low Cost Attritable Aircraft Initiative, with this concept of attrition tolerance, we've sort of been more risk tolerant, if you will, or less risk averse than some of our industry partners on that, where they don't want to lose a valuable test asset, right? And we're of the mindset that no, you can just design another one, build another one, and we'll replace it and then fly some more. We'll learn more quickly that way. Yeah. So it's been an interesting play back and forth, and I just wanted to kind of update my comments on that.
No, for sure. Yeah, I mean, it's hard to give a one-size-fits-all answer is kind of, I think, what all of you are trying to say, right? But it does sound like the good news is that, as Peter sort of mentioned too, like the acquisition process is changing, right? We're trying to get tighter integration between operator requirements and what industry is doing so that regardless if it ends up being the government sort of sharing more of the cost or industry or what have you, at least we know it's going to the right place. That's kind of the important part. Maybe along a similar note, so similar kind of program theme question here. Do you think the next generation of military personnel are equipped with the necessary skills to be successful without, sorry, I'll have to sort of tweak this a little bit, to be successful, I guess, in an era where AI and automation are going to be increasingly available? And what needs to change about maybe fourth generation practices to prepare for this?
So, yeah, that's a really, really good question. I like it. I think there can be a lot of misunderstandings when it comes to it. And one of the challenges, and I was talking with a colleague about this, is the democratization of AI. Because it's so available, we get a lot of people that are aware of it. And even just recently, I had an individual come up to me, and because of a change of policy and risk of losing some data, he was very strong, like, no, we need this. Data is gold. Data is the new gold. We got to have the data, and we got to use it for the AI. This is so important. And it was kind of a case where you're like, okay, I didn't want to discourage him for his interest in the data, but at the same time, no, you're not really understanding the problem domain. And I think what happens, and I've heard this a lot from some colleagues where we say, you know what, the new generation coming in, they're going to be so used to anything digital. They're all using it, and yeah, they'll adapt to it quickly. And I don't necessarily believe that. To use an analogy, like, yes, a lot of people have electronic devices now, and they're used to all that. More people are driving cars now. Cars are everywhere. But that doesn't mean that they are experts on maintaining their vehicle. This isn't the 60s where people are doing their own oil changes. Because the technology is so out there and we use it all the time, we're not experts. I can't change the oil in my car. And I think that's part of the risk with AI is that sometimes we think that because the technology is so persuasive, that, yeah, everybody's just going to naturally adopt to it. And I've already encountered people where it's almost a duality, where you get some people who really want to use AI, And then you get other people who are afraid to give up that control and allow the machine to do it, believing that, no, I still need to be in that decision process. So I think there's going to be some challenges. And to be fair, I mean, that's just my own personal opinion on it.
Oh man, yeah. I mean, I think from the Air Force perspective, I've heard the term multi-capable airman thrown about, especially when we're trying to get retrained on new environments to operate in. With this, I think about the young kids growing up and everybody's using the tablet versus maybe my parents that will not transition to something touchscreen based or tablet based. But for like advancing us in the future, I see autonomy and AI. Really, what that does is that changes the bar or requirement to entry of like memorizing thousands of pages of like how to like keep the engine safe when I'm flying the aircraft, or how to employ and what all the symbology means to be soon a lot more like simplified, like aggregated information to make easier decision on the glass. That's where I see it, and there you can start to maybe more generalize some like specialty codes. You can group different folks together, and not just like single airframe, but maybe multi, or really just the multi-role capabilities really start to expand when you talk about like tactically proficient aircrew aviators.
Okay, those are great perspectives. I guess there's an important distinction to be made between being an operator of the AI versus knowing how to develop and sustain it. Those are different skill sets, and like you guys have all said, it's another tool in the toolbox. So I guess that helps too. Maybe a very specific question here from the audience. So I'll try to broaden it a bit because I think this one's quite niche. But as we see more and more autonomous platforms coming into use, CCAs in particular, what do you envision as being the role of crewed fighters or bombers? Like a lot of the discussions we have right now are about CCAs supporting state-of-the-art fighters, or air-launched effects that are maybe supporting some slower-moving tactical aviation aircraft. Are there other teaming architectures that are of interest that you're thinking about? Are there sort of evolving roles for the human in this that you'd be open to sharing?
I'll kickstart it. So the whole point of having any of these tools in the toolbox is to achieve a mission objective. Like, fighters don't exist for their own benefit. They serve to provide capabilities to achieve a mission objective. Submarines, it's everything that the military does, or international allies and partners. Every tool that you use in your Department of Ministry of Defense is to be used to achieve a military objective. And I think we will still have preeminent importance of the operators or those decision makers ensuring, whether it's an autonomous system or a crewed system, is collaborating effectively and packaged effectively to achieve that overall tactical, operational, strategic outcome. So I think we don't need to, we can't get more specific than that, but I think it is kind of irrelevant whether it's a fighter pilot or bomber pilot or somebody in the back of a AWACS or somebody in the KAOC, whatever it is. The most important thing is that these things are working to achieve overall mission objectives, and that's what we're trying to provide.
Yeah, we talk a lot about threat risk. We talk about acceptable loss ratios when you integrate like manned platforms and throwing them into the lion's den. This is where we are actually maybe able to transition some of that risk forward and still stage with those quarterback type scenarios, or find new ways to offload the more mundane tasks to throw ahead for battle space awareness, characterization of the environment, all those things that are very tedious, take a ton of time, and maybe don't need all of those humans in the loop, especially if they don't have those kinetic fires. Sure.
Now, there's a very famous list in human factors called Fitts list, and it's what humans are better at and what machines are better at. And I think that's what we really need to consider going forward when we talk about crewed and uncrewed platforms. The humans, us, will always bring in unique abilities, unique skills that AI won't be able to do. We discount, I really do think we discount the power of the human brain sometimes. And for example, like what we call instinct. There's research out there that says like instinct isn't instinct. It's actually our decisions based off of decades of learned experience. And unlike an AI that could trace back how it made its decision, we may not be able to, but it's still founded on our own experiences, and it's a very, very strong thing. And so that's where that integration of saying, all right, how do we still bring the human in? Use the human strengths to overcome the AI's weaknesses and vice versa. To your point, absolutely. Like the role of the human will change. We'll find ways to reduce the workload, but it's not about eliminating one or the other, but finding that right way to integrate both of them in. And so, yeah, with AI, you may now have it with that idea of instead of a human controlling 1 or 2 or 5 drones, the human is now controlling 20 of them in a complex tactical environment. The AI is handling the tasks it's good at, but we've designed it in a way that the human is using their strengths in order to accomplish the mission.
I like that balance of perspective. I think I was talking to an Army doctrine officer not too long ago, and basically he said, we keep changing the terms from generation to generation, but fundamentally the principles of war are the same, right? The functions of air power, be it air mobility, offensive or defensive, action, those have all stayed the same. The roles are still there, but maybe there's an opportunity to look at the specifics of individual task allocation that will gradually change this. But maybe that's more of a discussion as opposed to operators just saying we want this architecture. Nice. Another specific question. Maybe this one's a bit of more of an engineering question, but how are each of you thinking about the way that CCAs or aircraft need to convey information to be able to convey intent? So if you are delegating more and more authority to these CCAs, what kind of information do you think mission commanders or pilots in command need to have in order to trust and also effectively operate these systems? Yeah.
I think frankly, I think the most important issue there is calibration. What information, not just what information, but when, how much, how densely. Again, you don't want to overpower the human with just a massive, you could just say, give me all the information, right? That's too much. And what is the appropriate amount of information in this particular moment may not be the appropriate amount of information in a different moment, depending on what's going on with the humans. It gets back to the collaboration thing. Understanding that is something that, like was said earlier, there isn't necessarily a lot of research that has been definitive there, right? So again, this gets back to the need to test it, figure it out, right? We don't know exactly yet. We need to test these things. We need to try these things and iteratively improve our understanding of how this collaboration needs to go. Right? And that's, this isn't about, well, which technology do we need or which approach do we need? It's about having a process to develop our understanding of these things so that we can create CCAs and things like it that are effective. So that's my answer.
Jeremy, I'm gonna give a classic weapons school example.
Yeah.
Or weapons school answer, I should say, which is it depends. I actually believe that this is going to end up being a sliding scale and requires very deep collaboration between the customer base and those who are delivering the capability. Yeah. I'll give a couple of examples on ends of the scale, and somebody else can tell me I'm wrong, and I'll be okay with that. But on one end of the scale, you might have a small UAS that has a relatively small lethal payload on it. I'm going after a high-risk, high-value target, and I've got a non-deterministic algorithm, that's part of both its mission autonomy and flight autonomy that is going to allow it to go identify, and then deliver lethal effects against the target. And all I need is a mission complete transmission before it terminates. At the other end of the scale, I may need very intensive feedback from the platform, whether that's based on ROE or I'm bringing much more significant effects to the fight, and I need a human on the loop or in the loop even to consent to taking out a target. So I think that's a conversation that we've got to have going forward.
I actually really like the way that you just framed that, and I think to again level set, like where are we right now as like maybe the point of departure in real world operations. When say a 4-ship of fighters or what have you go out, they do have already pre-existing contracts and agreements between them of who's going to be targeting whose responsibility is to search which area, and then what are you going to say and when you're going to say whatever you're saying on the radio. Or maybe you don't, and you communicate all that via our avionics in displays. And so that right now, how do you communicate intent between even just crewed platforms? You see the other person's track direction. You see on the glass, they've targeted that contact. And that is in accordance with what you thought they were going to do. So on the scale that you just described, I think is pretty reasonable. Even with all crewed platforms in the air, it's closer to the more end than it is on the less end more often than not.
That human-machine interface is super important, and we're absolutely looking into that from the developmental flight test world of how do you understand what the conditions or the run conditions and how are they going to be completing. And we're looking at everything from like tablet designs to eyebrow lights somewhere close to the HUD that's within maybe a field of view, especially if you're looking outside, all the way into helmet mounted like injection of different like parameters or signals or like color codes on glass. Like it is extremely complex. And I think to add on to Scar's point, it really does come to like those contracts and the training that goes into it, because that rehearsal space of, yes, I know how to operate with a wingman because maybe I've flown with them for 2 years and I know their tendencies. But if we were to field some of these agents right there in those collaborative platforms, how am I going to know maybe for a new flight lead how that AI agent behaves in different risk scenarios and different threat environments? And do we have enough like rehearsal environment and operational test like background to know how that thing handles itself? Certainly for the administrative tasks, that human-machine interface is very, very easy. And I think one of the most classical examples of automation, which is again the many different layers of that those big buzzwords, is with the ground collision avoidance in the F-16. Yes, in development, there was quite a bit of human-machine interface and like testing and evaluation of how much do we need to feed to the operator the fact that the aircraft has already decided you are on a collision course with the ground. It is an immovable object, and we need to get away from that. And yes, there are different chevrons that come in. That maybe there's different symbology, but at the end of the day, there's very minimal that you actually need to feed to the to the operator there in the seat on the system, trying to utilize that platform for its intended purpose, not for those administrative tasks. So yeah, there's very easy and like simplified systems that I think are already in place on all of our advanced platforms and as well as in future systems. And until we can really stress test all the scenarios, will we maybe think about like new ways to have the human like connect with the intent and the awareness beyond the classic like lock lines. Yes, go forth and conquer, and then come back to me and tell me when you're done.
Yeah, okay, I like that reference back to sort of existing precedents in GCAS and targeting systems. Yeah. Do you want to say something?
Thinking back to early days in this initiative when we started, I led an in-house clean sheet design team. And we explored the design space for this type of aircraft. And to support that, we developed a multidisciplinary analysis process that we then, first we integrated the components together, so each discipline had its component analysis, and then we integrated the pieces together. Then we would do, some initial trade studies to make sure that things were kind of going as we thought they would. And when you see something that's non-intuitive or that doesn't, a component doesn't behave as you expected, that's when you start to dig in and say, hey, why didn't this do what I thought it was going to? And so I think like these other folks were saying, we need those kinds of test events or things to happen so that we can kind of dig into the data. We need to also be able to capture that level of data, maybe not expose it to the user as much, but you can still go and dig into it after the fact if you saw something that you didn't expect. So maybe then you can get to the point of automating the entire process and getting to that kind of higher level of just observing and watching
Yeah.
That's really important. The point you just made, explainability is not just important for the operator. It's extremely important for the engineer who's trying to figure out why this thing isn't working the way it's supposed to, right? Again, that's why you need test early and often in the program. It's because if the engineer, and people who've studied AI know this, is quite often the AI will do something and the engineer who just coded it up went, I have no idea why it's behaving the way it's doing. So yeah, explainability is critical for at every point in the development process and absolutely in fielding. And having that relationship between the operators and pilots and the people who are going to be using it and the engineers, having a loop between them is just really important.
Yeah, I think as this discussion has evolved, I find it very interesting. Like I feel like aviation has obviously a very long history of developing safety critical systems, but over the course of these successive questions, it's become clear, I think, Scar, you had alluded to it, but a lot of this is we are now learning from what the software industry has done in terms of iterative experimental development and bringing those two worlds together, right?
And learning where the stuff that is done in the software world has limitations too.
Yes.
Right?
Yeah.
For instance, one of the big ways for safety critical systems in software, one of the most important methods historically has been something called formal methods, which is a great way to formally prove that this thing is going to stay within these bounds. But it doesn't scale that well when you're using algorithms that have massive, numbers of degrees of freedom.
Yeah.
Right? And so figuring, and DARPA's investing a lot in this right now, right? How do you make something like a formal methods type approach scale to the kinds of algorithms and kinds of open world systems that we're creating? That's a big open question, and the solution to which will really blow the world wide open in terms of autonomy.
Yeah, for sure.
I mean, this is a complex problem, right? And I would say humans always go back to rules of thumb or like general like notions. Until we can get to define like which agent, performer or like group set has these kinds of rules of thumb, I think we're still going to be spinning through that rehearsal space. And that's where a lot of attention is being focused in the DoD.
Yeah. Yeah, and I guess we can't really discount the value of that training and familiarization, kind of tactics, techniques, procedures, development process is equally important to the technical capabilities that are being provided, right? Yeah. We're getting pretty close to our time here, so I'm going to ask one last question from the audience, and then I'll switch to sort of a rapid-fire Q&A to end things off. Last question from the audience here. So we've obviously had a bit of a kumbaya here, right? Very positive about collaborative autonomy and AI and the capabilities. One question here is, what are some of the maybe vulnerabilities that AI might inadvertently bring to military platforms, and how do you sort of envision those risks being managed?
AI famously has the ability to be manipulated by people who understand it. Right. So there was a famous case many years ago now where someone figured out they could make self-driving cars think a stop sign was a yield sign or something like that. Just by putting a Post-it note in one particular spot, right, is a famous case. So AI can be manipulated, right? The training data that was used to train it can be reverse engineered, right? So there are, as with any new technology, there are risks that come with that. And again, the answer to it comes back to engineering and testing and training and close collaboration between the users and the developers, right? So it absolutely brings new risks. And we know how to approach those risks, which is, again, as we always have, by rigorous engineering principles and testing.
Yeah.
I would say there's a framework that's used certainly in the Air Force fighter world, and I think it has been adopted by others as well, is perception, decision, execution. It's going to lead exactly into what you said, where if you have you perceive A, you're going to then decide to do something against A and then execute that action that you decided to do based on what you saw. And so if the AI agent perceives something wrong, it could then decide something wrong and then execute that very well. And so we want to make sure that we have assured and trusted ways that it can handle noisy data or poor perception and still make decisions that are within a framework that's acceptable. And then there's little doubt in my mind that an AI agent is a better pilot than any of us could ever be. It will control the flight control surfaces down to a degree of accuracy that we never could. So there's no doubt it will execute outstanding flight of the aircraft, but it has to have good decision making, and that all the way comes up to that perception. That is a stop sign. It's not a yield sign. So then decide and then act.
So yeah, so I find there's a couple points with that. One is when we talk about hallucinations, that's something that I say that one of the hardest things for AI to do is to say, I don't know. I mean, it's designed to provide an answer and come up with something. So what happens when it doesn't know, but it still tries to produce an answer?
Right.
And that's where we run into situations. We all know the famous saying, garbage in, garbage out. And I heard a variant of it that I prefer much more, and it's garbage in, gospel out. That unfortunately, if we get an answer that's within the realm of possibilities, we just accept it. And we go with it. So that's one of the challenges with the hallucination. Yeah. The other challenge I find with AI is we talk a lot about the data, and it's true. You get the bad data, you get the biases in the data, but we forget the second big component to an AI is the algorithm. Mm-hmm. And a poorly designed algorithm can turn good data into that garbage. And we've seen examples of that in different AI platforms and all that. So that's the other consideration too. It's not just the data, but getting the algorithms right for it. So yeah, it's a huge challenge that I know it's one I'm trying to work with and address for the Canadian Armed Forces is how we go forward with it. Because that's part of my experience with working with software is especially like from the industry viewpoint to the client, you kind of only get one chance. And if you produce a product that's bad, people in the military will talk about it. And I've seen that firsthand. And it doesn't matter if 10 years later you've solved the problem, it works great, it still leaves a bad taste in people's mouths. So it's, yeah, it's a big challenge.
One of the big things that we're focusing on in specifically in our F-16 Venom program is on the cyber resilience and all of the ATOs and authority to operates, authority to connects, and making sure that we are going through very deliberate steps to ensure the safety, security, the boundary conditions for where the data goes inside the platform, outside the platform as well. So controlling those, in the 96 test wing, we have entire squadrons dedicated to that, looking at hardware, software, and all the connections in between.
Yeah, I guess another perspective just to add to that is, we talk about vulnerabilities. We often think of vulnerabilities on our side. Oh, sorry. But there are also vulnerabilities on the adversarial side, which then become exploitable, right? Mm-hmm. So as much as they are concerns for us, they're also opportunities in the right context. Yeah. Okay. Oh. No. Okay. All right. Yeah, we're getting pretty close to the end here, and like I said, I would do some rapid fire Q&A just to kind of get the blood flowing and make sure we end on a high note. So I'm going to go sort of in order, maybe starting with Scar. Sorry to throw you under the bus, so to speak. But first question is going to be, what is your favorite aircraft and why?
The Raptor. Next question.
Okay. Wow. That was a fighter pilot answer for sure. And then the second question is, if you could offer one piece of advice to your younger self, what would you give?
That's a good one. I would say don't fight to leave adversity. It's going to make you who you are.
I like that. Peter?
So favorite airplane, I'm going to split the baby. So I'm going to take an F-35 to war, but the F-18 is always going to be closest to my heart. And on the what would I tell my younger self, it's authenticity and humility will serve you well throughout your life. Don't follow the herd.
Nice.
All right, so it's hard, you can't compare Jordan and LeBron, right? So I'm gonna pick two from two different eras. The B-2, I've always been absolutely enamored of the B-2, but probably my the GOAT has got to be the first one, the first airplane, the Wright brothers. Yeah, they solved fundamental problems that in building, and they didn't just throw that together in the bicycle shop. It was an amazing technological feat, and I love that one. So, advice to self: take more risks, meet more people. Awesome. Collaborate and take risks.
Cool. As a developmental test pilot, that first question is always near impossible. But I'll say that no one forgets their first love. The Strike Eagle is very near and dear to my heart, and I'm very excited to be qualified back in it, especially as we're taking it into its new paces with the F-15EX. The second question, what would you tell yourself? I would say just never be content. There's always more information out there. There's more learning to do. There's more perspectives that grows you as a human and makes you into a better person.
For favorite aircraft, I mean, besides the XQs and the YFQs, those are of course very close to my heart right now. SR-71, XB-70, X-15. I love the experimental aircraft. I think as a child, B-2, F-14 were really the ones that got me into wanting to pursue military aircraft development and interested in design. So I don't know, it's hard to pick.
Number of aircraft is increasing as we go. That's okay, yeah.
By the way, you can see them all at the United States Air Force National Museum in Dayton near Wright-Patterson, which is where I reside. And feel free to hit me up. I'll give you a private tour, guided tour, anytime.
Okay, awesome.
And in terms of advice to myself, I think that was the question, right?
That's the second question, yeah.
Cherish the moment, embrace it, and try to stretch it out as much as possible. You never know, when something else might come up, and then the moment is over. So try to enjoy it as much as you can.
So yeah, I guess I'll keep going with the theme of picking two aircraft at least. I'll go with my first love as well, CP-140 Aurora, as we like to call her, the sleek greyhound of death. Wonderful plane. And I'll give an absolute Canadian answer, the legend that died well before her time, the Avro Arrow. It's always a good question. Advice to myself. I think one of the biggest things I would say is seek those opportunities. Don't be afraid of the opportunities that nobody else wants. And I've had that. I've been to units and squadrons that people considered almost dumping grounds where the careers go to die. And those were the places that got me promoted. That I found the opportunities in there that nobody else was looking for and seized them. So yeah, that would be my advice.
Fantastic. What a great way to close off this panel. That was fantastic. Let's give a round of applause to our panelists. Hey, that concludes this Forum 360. I don't know if you guys will be around to take sort of informal questions afterwards, but I want to thank all the audience members for the fantastic questions and wishing you all a great rest of your day.